All right, so multiplying and dividing integers. When you multiply and divide positive and negative numbers, the only thing that's different than multiplying numbers like you've been doing, which, by the way, have always been positive, is just whether or not the outcome is positive or negative. You still multiply the same way. So, for example, if I said 5 times negative 9, well, 5 times 9 is 45, regardless of whether one of the numbers is negative or both of the numbers are negative. Okay? You just have to figure out whether you're getting a positive 45 or a negative 45. So right now we're going to talk about what happens when you multiply different combinations of positive and negative numbers. So, let's look at the first example, or the first thing. Positive times, by the way, that dot means multiply, okay? I'm going to be using that dot a lot instead of a little X that you guys use or are used to seeing. And that's because later on we're going to use variables, and seeing a multiplication X next to a time symbol is going to get a little confusing. So, a positive times a positive. Well, you've been doing this your whole lives pretty much whenever you've been multiplying. Positive times positive just gives me a positive. For example, if I did 4 times 3, that gives me 12. Remember that dot right here means multiply. Now, what happens if we take a positive and multiply it by a negative? Well, in this case, if I take a positive times a negative, the negative is going to be a little stronger and it's going to win out, okay? So that's going to give me a negative outcome. So anytime, whether it's a positive times a negative or a negative times a positive, my answer is always going to be negative. Okay, so if I have 4 times negative 3, that's going to give me negative 12. And if I have negative 3 times 4, that's going to give me negative 12. Okay, doesn't matter whether the negative is first or second, you're always going to get a negative number when multiplying a negative times a positive or a positive times a negative. And then, here's a third one. What if I've got a negative times a negative? When you're looking at this, I want you to think about what happened when I subtracted a negative. Subtracting a negative was the same thing as adding a positive, right? Well, negative times a negative, those two negatives cancel each other out, and I actually end up with a positive. So if I had negative 7 times negative 6, 7 times 6 is 42, and a negative times a negative is positive, so I get positive 42. And the same thing works with division, okay? I can replace all of these multiplication symbols with division, and I get the same thing. In fact, I can just rewrite that. So let's do that. Positive divided by positive. Why did I write it this way? I could have written it with a division symbol, but remember, a fraction bar means divide. Anytime you see a fraction bar, it means that the numerator is divided by the denominator. So positive divided by a positive is a positive. An example of that, if I have 6 divided by 2, 6 divided by 2 is positive 3. if I have a positive over a negative, or a negative over a positive, it doesn't matter what order it's going in. This is the same thing as me saying, oops, I didn't actually say this. This gives me a negative. An example of this is, let's say, negative 8 divided by 4. Oh, sorry, we did positive over negative. That's okay. That's why we have erasers. So 8 divided by negative 4. 8 divided by 4 is 2. Positive divided by negative is a negative. And the same thing happens if I have a negative over a positive. That's also a negative. So this time if I have negative 9 over 3, that gives me negative 3. Because 9 divided by 3 is 3, and a negative divided by a positive is a negative. And finally, if I have a negative over a negative, that gives me a positive. So if I have negative 10 divided by negative 2, that gives me positive 5. Now, I want you to think about really quickly what's happening here. Notice where the negatives are. In the first two, the 8 divided by 4, the 8 divided by negative 4 and the negative 9 divided by positive 3, there's one negative symbol, which means only one of these two integers is negative. But the outcome is completely negative, correct? Now here there's two negatives, which meant the 10 was negative and the 2 was negative. So what I want you to understand is if I have a fraction, okay, if I have a fraction